This strategy is called doubles plus 1, or some students prefer to have doubles minus 1. I'll show you that as well. But doubles plus 1 means we're going to use our doubles that we already know and now extend it to be doubles plus 1 for any two numbers that are just 1 apart. So for example, 5 plus 6. We can think of that 6 as being a 5 and a 1, which has in it another 5 to make our doubles with our first 5. So it's being able to break apart that second number when they're 1 apart and seeing that it's made up of a doubles plus just 1 more. Or you can do doubles with a larger number and take away 1, but whichever way the students like better. They do have their favorite methods, and the understanding is they can use whatever method works best for them. There is no one right way. We want to teach that throughout all our math instruction, that there are a variety of ways for us to get to the answer, and some of them are more efficient for different people's brains than others. So you want to find the ones that work for your brain and do the one that's most efficient for you. Go. So we'll use the Record first to show a doubles plus 1 strategy. So let's say we were going to be adding 5 plus 6. I'll slide over my 5, and I'll slide over 6. We want the children to be able to see how this 5 and this 6, within this 6 is another 5. And I know my doubles. I know 5 and 5 make 10. So 5 plus 6, since 6 is just 1 more than 5, must be 1 more than that 10. It must be an 11. The children can also think about it as being 2 6s, taking away 1. So 6 and 6 they might know is 12, take away 1, it must be an 11. So let's take a look at 6 plus 7. So I have 6 and my 7 is made up of our 5 and our 5, and then 3 more. Some students actually do think of it that way when they think of the 6 and the 7. They like using their benchmarks of 5s. But we want to encourage them in the strategy for doubles plus 1 to see that there's 6, and within that 7 there's a 6 and a 1. So you have your 6 and 6, which if you know your doubles facts from the previous strategy, you know 6 and 6 make a 12, then 6 and 7 must be 1 more than that, because 7 is just 1 more than that 6. We could then, let's do 8 plus 9. So if we have an 8, and then we slide over our 9, within this 9 is made up of another 8. So if you know 8 and 8 make the 16 from our previous doubles work, then we know that it must be 1 more than that. It must be 8 and 8 make 16, 1 more makes 17. Or some students actually do like to do doubles minus 1. They like to think about it as being, well, 2 9s is 18, so 1 less must be 17. So it's a great tool to visualize that doubles plus 1. With the Cuisenaire rods, let's say we're going to be adding 5 plus 6. We're going to think about this 6 as being made up of a 5 and a 1. So I'm going to line it up to show you how that can equally match up there. And what I'm going to do is take away the 6 rod now and replace it with the equivalent 5 plus 1. So you can see how it's 5 and 5 make that 10, and 1 more makes an 11. So 5 plus 6 can be thought of as being 5 plus 1. Or some students do like to think about it as being 2 6s is 12 and take away 1. So it's up to whatever works better for their brain. And here's a model for 8 plus 9. Within this 9 rod, there's an 8 and 1 more. So we can visualize that by that and show how it just exactly lines up. So we're going to think about it as being an 8 and 8 plus 1 more. So we have 8 and 8 being 16, 1 more makes 17. And again, some students do the 9 plus 9 is 18, and take away 1 is a 17. So whatever way works best for their brain.